That's the kind of the theme for the whole unit, or at least the quadratic equation part.
If you find more typos, can you put them to the next quarter?
Yeah, bank them, save them, and then submit them next quarter. Yeah, totally. Right.
I'm too oblivious. I just read it.
So, quadratic equations. That's the solving quadratic equations. The theme for the unit. It's the title. We're going to start off by solving them by factoring, which is related to what we just finished, the unit on factoring. So that's good news because we can take our skills from the last unit and put it to work immediately. So if you were strong in factoring, I mean, personally as a student, I always hated it when I spent a lot of time to learn something, and then in the next unit it was completely tossed out the window and we learned something completely different. I was like, well, why did I study all that? It's gone now. And then sometimes it never came back again. Here you have the benefit of being able to apply what you learned immediately. All right? And also the benefit of taking something that maybe if you were struggling, you can still reinforce those skills and still learn it and apply it as we go forward. So it's kind of like in the second crack at that content if you did struggle with it. All right? So that's good news. All right? I did mention in the last unit that factoring is a concept that's never going to go away, like ever. So you definitely want to kind of make your peace with that. We're going to start off with something called the zero product property. Factoring, solving quadratics by factoring. We'll talk about what a quadratic is. So that's an important concept. And then later on, we'll get into some topics where we have to get a solution to a quadratic, but the solutions won't be nice, neat numbers like x equals 2 and negative 1/2. It's going to be like the square root of 2 over 2. You know, or 3 plus or minus radical 7 over 4. You know, or some funky decimals that your calculator will give you. Right? And I'll also show you how to write a program in your calculator to come up with the solutions to these quadratics that you can use as a checking mechanism. So it'll be pretty cool. Actually, if we have time, I might show you how to do that today. Because, you know, I sometimes can't resist. The first set of problems is zero product property. I'll just read it. If the product of two factors is equal to 0, then at least one of the factors must be 0. Right? And that has to do with the commutative property. Like if you're going to deal, or even more basic than that, the properties of numbers that we talked about in the first unit, it's the zero property. You multiply by 0, you get 0. All right? So what this is telling us is that if I want this equation to be equal to 0, either factor could be equal to 0. So I have a factor of x, and I have a factor of x minus 5. What I can do is I can take the x and set it equal to 0. Bless you. I could take the x minus 5 and set it equal to 0. And then solve each of those. So I don't know, the one in blue is already solved, x equals 0. The other one, just add 5 to both sides. And you get, I'll go red there, x equals 5. All right? So we would get two solutions, 0 and 5, because what would happen is if I were to plug a 0 in for x, I'd get 0 times negative 5, which is 0. If I plugged in a 5, I'd get 5 times 0, which is 0. So either of these two solutions would work. All right? So we would denote our final answer by saying that the solution is x such that x would be equal to 0 or 5. All right, there's other ways you could write it. We talked about this when we were dealing with systems. You know, this is the fancy math way of writing it. The cool way to write it, if you want to be like a cool math person. Some people would define cool math person as being absolutely not cool. But I think it's kind of nice. I did see some people writing answers to problems on the benchmark yesterday. There was one involving a system using this correct notation. It was nice, you know, because we haven't done it in a while, and usually the notation is the first thing to go out the window when enough time has passed by. So, but the fact that some people were able to bring it back was kind of nice. So, okay, so you don't want to write it like that. You could write it as x equals 0 or x equals 5. You know, with the v representing the or. Or if you want to go, I mean, you do it like this too. You could actually write out the word or. I mean, it's alright, I guess. I mean, you get full credit, so it's fine. I mean, really, in the grand scheme of things, that's what you're looking for. But, I mean, that looks so fancy. You know, it looks like you really know what you're talking about there. You know, somebody looking over your shoulder and they see you write that, they're like, whoa, what are you working on? You work for NASA or something? Like, no, I'm just doing some freshman algebra. They're like, whoa, what school do you go to? You know, like they'll be very impressed. All right. Same idea for number 2. Each of the factors you set equal to 0. And then solve. You don't need to show the work. It's got to be add 5 to both sides, you get x equals 5. Subtract 3 from both sides, you get x equals -3. So my solution would be, we're only talking about x here, not x and y, it's just x, such that x would be equal to either, I like to put the smaller value first, but it doesn't matter, -3 or 5. Oh, my squiggly bracket lost a little bit of oomph at the end, so I'm going to undo and bring that back. All right, so again, you can write it in either order. I like to write the smaller number first. Just personal preference. It's not really a personal preference. It's kind of like what everybody wants you to write, but we'll take 5 for -3. Quadratic equations. Fancy term for a not so complicated concept. A quadratic equation is just a polynomial equation that's we call order 2 or degree 2. That's the important piece there. It's degree 2. Or a second degree polynomial equation. A lot of fancy words here. All it's telling us is that the polynomial in our equation has to have a high power of 2. No higher power than that. So you won't see any cubics, you won't see anything raised to the 3rd power, 4th power, 10th power. You won't see any radicals, so nothing like that. You won't see any fractions, at least not in the early going. It's just simply going to be in this form. And if it's not in that form, you're going to put it in that form. All right? So what you're going to do is you're going to be given a quadratic equation in whatever form they're giving it to you in. Then you're going to get it in the appropriate form. After that, you're going to factor the polynomial. All right? So you need to know how to factor. Once you factor, you're going to use the techniques that we learned about yesterday in that worksheet, and we just reviewed today in the what should have been called a do now, but it wasn't for some reason. So,
What? Got it. Yeah, there's like 5 pages of full punch.
so x squared minus x, I'm going to write -6 equals 0 to get it in the appropriate form. All right, so all I did was I subtracted the 6 from both sides. Eventually, you're going to want to move away from the x chart. You know, try to do it in your head, but if you're not there, you're not there. For some people, it takes years. It took me a while. I didn't even see the point, so I just didn't pay attention. I was like, what is this? It just seems stupid. I don't want to factor. And then, like, a year and a half later, I was like, all right, I better learn this because it seems like it's coming up over and over again. So, you know, some of us get to the party a little late. If that's the case, I mean, as long as you get there at some point, I guess it'll be fine, but the sooner the better. All right. So, x and x, right? It's just going to multiply to x squared. So I need 2 values that are going to multiply to -6 that are also going to add to a -1. So if you want to do the x chart, do the x chart. What do you got? 3 and negative 2? Negative 3 and positive 2. All right. So then take each of your factors, set them equal to 0. Some people make a little t-chart. Just keep it organized. You do that. X minus 3 equals 0. X plus 2 equals 0. Add 3 to both sides. X equals 3. Subtract 2 from both sides. X equals negative 2. And you have your solution. X. I'm losing my squiggly bracket powers. X such that X is equal to negative 2 or 3. All right.
Oh, yeah.
All right, so again, all this means is that either negative 2 or 3 will satisfy this equation. And depending on the situation, you might want the negative 2, you might want the positive 3. Some word problems that we've come across, they deal with geometry, rectangular regions and things like that. If X represents the length of a side, you probably don't want the negative. If X represents a time, maybe you do want the negative, because it could just be 2 seconds before the moment that you're collecting the information. Right? So there's a lot of possibilities there. All right? But basically any problem that I throw at you, at least in the early going, is going to take on that form. All right? So you can see the equations below, like for example, number 1, it's not in the right form. It's got to be equal to 0. Same thing with number 4. So get it in the right form. So I'm going to subtract an x from both sides. We're not just limited to trinomial factoring. In this case, what kind of factoring would I be using? I don't think I heard the correct answer yet. Maybe it was said, but I don't think I heard. Negatory on the trinomial. It would have to. There would have to be 3 terms. 3 for the tri. There's only 2 terms. Don't count the equals. It's definitely binomial, but is it a difference of 2 squares? That's the only thing that's a perfect square. 7's not, and the x is not. What other technique? Greatest common factor. Always start with the greatest common factor. That should be the first thing you think of, not the last thing you think of. All right, so factor out an x. 7x minus 1 equals 0. Take each of your factors. You do the little t-chart if you want. Beep. X equals 0. 7x minus 1 equals 0. So the x equals 0 is already done. What am I going to do to the 7x minus 1 equals 0 to get x? 2 steps. Add 1, then stare at it lovingly. Divide by 7. All right. So we'll get 2 answers, x, such that x would be equal to 0 or 1/7. All right, so the factoring was easier, provided you recognize what type of factoring it was. Now, there is a most common error here that happens or has happened in the past, like half the class would get it wrong. But I'm worried that it's a self-fulfilling prophecy. By me saying what the error is, it puts in your mind something that you weren't even thinking of to begin with. So I'm not going to say what the error was.
What's the error?
Well, I'm telling you, I'm not going to say what the error is.
No, this is wrong.
No, this is fine. I'm just saying, like, if you, I'll just put it this way. If you had an approach in the beginning that took you in a completely different direction, right? So you tried the problem, you took a completely different approach, and because of that, you only got one of the 2 answers. Talk to me individually, and I'll tell you where you went wrong. Right? I don't want to point it out to everyone, because if I do, I'm going to create the problem that I'm trying to avoid. All right, but I do need to mention it because there is a common error that occurs for this particular type of problem. When you come across a question similar to this in the practice, you check your answer against the key. You see I have 2 answers, but you only have 1. Talk to me and I'll tell you what the problem was. All right, but I don't want to say it for everyone because I don't want to create the problem that I'm trying to avoid. All right. And it's kind of anticlimactic. There's no like Christopher Nolan twist at the end of the story. It's like you're not going to be excited by the revelation. All right, first move in number 4.
Split it down the middle.
Add 5. Now, splitting it down the middle would be a good idea if that equal sign wasn't there. Because then it would be 4 terms. You'd be thinking grouping, but the equal sign there changes everything. All right, so we have to factor this. It's a trinomial, 3 terms, so we know it's trinomial. So give me 2 values that'll multiply to 24, that'll also add to negative 11. Negative 8, negative 3. All right. All right, set each of the factors equal to 0 and solve. You get x equals 8 and x equals 3. All dependent on your first step. Because if you tried factoring the x squared minus 11x plus 19, it's over before you even begin. You're stuck. You're like, oh, what's going to multiply to 19 that allows it? It's game over. Game over, man. So x such that x is equal to 3 or 8.